Hi everyone, this is Sharan. Welcome to my channel. This is part of the journey of learning data science in 100 days, and today's topic is again about NumPy. Today we are going to see about iteration, manipulation, as well as creating an array with random numbers. So the first one is iteration. So here we are going to see how to iterate through an one-dimensional array, two-dimensional, as well as three-dimensional array. This will be very useful when we have a data set in an array format and we want to access the elements of an array. So this array can be n-dimensional, that it can be with any dimension, and if we want to access the elements of those array, we need to know how to create or how to iterate through the elements of those array. So we will be exactly learning to implement it using NumPy in Python. And the second one is manipulation. So here we will be specifically seeing through how to like reshape or manipulate an one-dimensional array into an n-dimensional. Usually, like when creating an n-dimensional array, we would have a list of values, a list of elements, and depending upon the length of the elements and depending upon the requirement, we might have to reshape it into a specific two-dimensional, three-dimensional, or like n-dimensional array. As well as in some other cases, there could be an array with n dimensions and we might have to flatten them back into one dimension. So we will also be going through how to do all these things, as well as how to transpose an array, and finally about creating random numbers and how to create an array with random numbers. So here a two-dimensional array can also be called as matrix. So we will be going through an example of creating an matrix with an random numbers. So that's about the topic that we are going to cover today. So let's go into the tutorial, and as usual, before going into the tutorial, if you liked this video or if you think this might be useful for any of your friends, please share it with them. And if you learn something new today, please click the like button as well as subscribe for more data science related contents. See you in the tutorial. As explained in the introduction today, so we are going to cover about iteration, manipulation, as well as random number generation, as well as creating an array with completely random numbers. Also specifying the distribution of how the random numbers should be generated. So we will go through those details one by one. So the first one is iteration. So we are going to see how to iterate through an one-dimensional, two-dimensional, as well as three-dimensional array. So in order to use all these functionalities, the first one is we need to import the NumPy package. So as usual, the first one is import NumPy as np. So we can whenever we want to call NumPy or use the NumPy package, we can use np and make use of all the functionalities of NumPy. So let me execute this, and so NumPy is all successfully it has been successfully installed, so it's been imported. So now in order to iterate through an one-dimensional array, so as you see on my screen, what I have here is a simple one-dimensional array with values from 1 to 5. Let's say we want to iterate through the elements of this array and we want to print the elements. So what we can do is we can simply implement our right and for loop, and we can specify x in array where x would be like all the elements of the array, and we can print x. So by default, x would iterate through like from the first element till the last element. So when I execute this one, so you can see the values are printed like 1, 2, 3, 4, 5. So in order to know exactly how this particular for loop is working, what we can do is we can initialize an value I is equal to 0, and let me increment the value of I by 1. So first, like initially the value of I is 0. When it goes into the loop, it will be incremented by 1, and hence like first time it should be printing 1, and so on. Like second time it will be incremented by 1 more and it should be printing 2. So let's see what's happening here. So when I do this one, so as you can see, along with the value of the element in the array, so we are also printing the value of 1, which is aligned with the values. Like it is clear that this for loop is going through all the elements one by one. So it loops through this array like 5 times and prints all the elements. So now let's go to the two-dimensional array and let's see what's happening over there. So here the two-dimensional array is simply like it has 2 rows and 5 columns, values from 1 to 10. So just in order to print and show you like how the array would look like, let me just print and show you like how it would look. So this is how the array would look like. So it has 2 rows and 5 columns. So what I'm going to do is I'm just going to now implement or write a for loop to print, like I'm making use of the same for loop that we did for one dimension. So for x in array 2, which is 2-dimensional array, print x. Let's see what's happening now. So when I write this one, so this belongs to this print statement here. So when I print x, so what's happening is it is printing the first row, like in the first time, and the second row. So when I use this and then print the value of y, we will exactly know like how it is going through the loop. So when I implement or when I execute this one, we can clearly see the first time when it is going through the array, it is printing the first row, like the first row of this particular 2-dimensional array. And second time when it is going through the loop, it prints the second row. So as we see here, the first row itself is having 5 different elements, but we are not going through each of those elements. So in case of a 2-dimensional array, when we use like just one for loop, what happens is it goes through only one dimension. So it goes through the rows. So let's say if I am going to have 3 rows here. So let's see what's happening here. So when I execute this, as you see here, it is going through the loop 3 times. So what's happening is when we have only one for loop, in case of a 2-dimensional array, it goes through only one dimension. So now let's say like in case of a 2-dimensional array, we want to go through element by element, like across like each element across all the dimensions. So let's say we want to print the value of 1, 2, 3 and so on, the value of each and every element of this particular 2-dimensional array. So then what we have to do is we have to implement like 2 for loops. So whenever it has 2 dimensions, we need to have 2 for loops. So depending upon the number of dimensions, we need to have the number of nested loops. For example, in case of a 3-dimensional array, we have to implement an nested for loop with 3 layers. So we will go into those details like very shortly. So this is how happens when we have just one for loop and when we want to iterate through the array. So this is how it gets printed. So now let's see the same thing in case of a 2-dimensional array. If we want to print each and every element, how can we do it? So as you see here, what's happening is I'm creating 2 for loops, like a nested for loop. So the first one will iterate through one of its dimension, and within the dimension, whenever there are multiple elements, so this second for loop will help in going through the elements of that particular dimension. So here the I in array 3, during the first time into the loop, it will select this particular array, and the second for loop that we have here will help us to iterate through the elements of this specific array. So that's how it would work. So let me execute this and show you how exactly it would work like. So as you see here, when we have 2 for loops, we are able to exactly access each and every single element. So the first time here, what happens is it goes through this, it selects this particular array, and the second for loop would help us in going through each one of these elements here. And second time when it comes into the array, when it goes into this particular for loop, what happens is it will increment and then it will select the second row, and the second for loop here will help us in going through each and every element within this particular for loop. So this is how we can access each and every element in case of an n-dimensional or in case of a 2-dimensional array here. So the same thing, like if we have 3 dimensions, so this is a 3-dimensional array. So let me, before going into the loop, let me just print and show you how this 3-dimensional array would look like. Okay, so this is how the 3-dimensional array is looking like. So it has 2 layers, like one array as well as second array. So each of these arrays are 2 dimensions. It has 2 rows and 5 columns. So let's see when we have just one for loop, like what happens here. So let me just print the values. So when I execute this, so what's happening is when we have just one for loop, it picks up the first dimension which has 2 rows in it. Like it has like one matrix in it. So a matrix is nothing but an array of 2 dimensions. So in case of a 3-dimensional array, the first time it goes into the loop, like when we have only one for loop, it picks up the first dimension, which is the first layer, which can also be called as an first matrix, and second time it picks up the second matrix. So each one of them is 2-dimensional. It has 2 rows and 5 columns. So as you see here, first time it prints the first matrix, and second time it prints the second one. So as you can see, like if we implement like a nested for loop, like with the 3 layers, so then with 3 levels, then we would be able to access each and every single element. So that's what exactly is happening here. So what I'm going to do is I'm going to have a 3-level nested for loop. So the first one will go through the first dimension, which will be accessing the particular matrix, two-dimensional array, and then the second for loop here would access the first element of this 2-dimensional array, which would be this one, and the third for loop here would help us in accessing each and every single granular elements of this particular for loop. So by implementing this 3-level, we will be able to access each and every single element in this array. So when I execute this, so as you see here, we are able to access each and every single element and print it. So this is how a for loop can be used to iterate through the various elements of this array. So depending upon the requirement, depending upon like how or which value you want to access, you can pick up and implement the for loop accordingly. And going through the next one, so next one is called as nditer, so which is very similar to what we did in in the for loop here. So but what happens here is, so when I execute, like you can clearly see what's happening here. So here, by using nditeration and specifying the array here, I am not implementing the nested array. I'm just using one for loop, but I'm able to access each and every single element of the array. So if I want to let me show you like what's happening here. So let me initialize I is equal to let me initialize maybe z is equal to 0 and z is equal to z plus 1 and print z. So as you see here, by implementing this, what happens is we are going through each and every single element without actually implementing like a nested for loop. So this makes it very simple. So in case of an n-dimensional array, like instead of having a nested for loop, which might become quite clumsy and it might be very difficult for us to exactly decode. So in those cases, we can make use of this nditer, which can be specifically used for an n-dimensional array, like to iterate through an n-dimensional array with just a single for loop and access each and every single element. So that's how it would be working. So now moving on to the second topic, which is manipulation. So here we are going to see how to create an n-dimensional array from an one-dimensional array, as well as how to flatten an n-dimensional array and how to do transpose. So let's take the first example here. So what we are going to do is we are going to create first an one-dimensional array. So what I'm going to use is I'm going to use a range functionality of NumPy, and I'm going to specify the values like number of elements or a number of values that needs to be created. So this will create a sequential, as you see, the values will be sequential. Like it will start with 0 and it will stop just one number. Like it will create 25 elements. So since it is starting with 0, it stops at 24. So now after creating this, let's say I want to reshape this into a specific array, like into a specific requirement. So it has 25 elements. Let's say I want to create an 2-dimensional array with 5 rows and 5 columns. What I can use is I can make use of the functionality called reshape. So here I specify the array as well as by using reshape, and then I'm specifying the dimensions here, like it needs to be 2 dimensions. I'm specifying that it needs to have 5 rows and 5 columns. So when I print this one, what happens is it creates an 2-dimensional array. So it was created from this 1 dimension, and then it is getting created as per what we specify here. So let's say I specify here as 30, and let me make this as 10 and 3. So let's see now what happens. Yeah, so as you see here, right, now when I have 30 elements, and then when I'm trying to reshape into 10 rows and 3 columns, so that's how it is getting generated. Like the first element, like first value here would be the first dimension number of rows, and this one would be the number of columns. So if you swap this, so then as you see what would happen is it would create an array with 3 rows and 10 columns. The one thing that you need to make sure is whatever values that you give here, it should exactly add up to the number of elements of the 1-dimensional array. So let's say I try to give value 11 here. So if it is 11 columns and 3 rows, like totally 33 elements, but we have only 30 elements. So let's see what happens here. So it throws up an error saying that can't reshape an array of size 30 into 3, 11, which is into, and so it needs 33 elements for us to reshape into this particular value. So that's how it would work, and that could be some requirement for you. Like that could be an 1-dimensional value list of values. You might have to reshape it into a specific array format. So then you can make use of this reshape functionality to manipulate as per the requirement. So the second one is how to flatten an n-dimensional array into an 1 dimension. So as you see here, so here the array 2 here, so it is a 2-dimensional one. It has 3 rows now and 10 columns. Let's say I want to flatten that. So what I can use is I can use a functionality of NumPy, which is called as flatten. So what it will do is it will flatten this n-dimensional array into 1 dimension. So it will go through the rows. It will take these elements first, and then it goes to the second row and brings up into the next to this one, and it will flatten it. So let me execute and show you what happens here. So as you see here, it goes through the rows, prints all the values, and then goes through the second row and prints and keep printing all the values, and then like it is finally creating an 1-dimensional out of this n-dimensional array. So let's say we have 3 dimensions. Let's say so this one is maybe 300 elements and 10. So let's see what happens now. So now what we have is we have a 3-dimensional array. So now when I try to flatten this, so as you see, like doesn't matter like whatever dimension we have, when we use flatten, what it does is it will create an 1-dimensional array. So this can also be useful when we have an complex list of values like in a multi-dimension, and we want to flatten that into 1 dimension for whatever purpose. So then maybe we can make use of the flatten functionality. And the next one is transposing an array. So let's say we have the values starting from 1, and then it goes through the columns here. So let's say that we want to transpose and then make it go through the rows. So when I use transpose, which is nothing but .t, yeah, so you can see that the values are being transposed here. So maybe to just explain it in a simple way, like maybe what I will do is I will just stick on to 2 dimension so that it becomes like clear like about what we are doing. So let me execute this, and let me use the transpose here. So as you see here, what we had is we had 3 rows and 10 columns. So when we did the transpose, it becomes 10 rows and 3 columns. So same thing, like whatever be the dimension, when we transpose it, it shifts the it shifts the array into into the alternate view. And moving on to the role axis. So what role axis does is it's exactly same as what we are doing for transpose in case of 2 dimension. So it will shift by 1 axis. So when we have 3 dimensions, like the way it would work would be slightly different, because like there are 3 dimensions, and it will shift through one of the dimension, like 1 axis, like all the values. So that's how the role axis would be used. So these are all some of the techniques that are used for data, like for array manipulation. And the few other techniques that we have already covered, or like in order to do manipulation, we can make use of join in order to join like multiple array into one, and we can use slice to just slice a small piece of an array, or to select a subset of an array. And the splitting is to split an array into multiple components or into multiple smaller arrays. So these are all already covered by us, so I'm not going through the details. So if you want to know about these specific details, you can go through the previous videos and then exactly learn about how to do or how to implement all these. The next one is random numbers. So random is one of the functionalities of NumPy. So it can be used to create a random value. So even though we have imported NumPy, so we need to import random in order to use this functionality. So without importing random, if I try to execute this, so as you see here, like it says that random is not defined yet. So you need to import random from NumPy. So let me execute this, and then let me execute this now. So as you see, this random functionality will create a random number, so between 0 and 1. So every time when I execute it, you can see it creates a different value. So let's say I want to make use of this random functionality and create a one-dimensional array. So what I can use is I can use a random int in order to create a random integer within like a value of 25. So here what happens is it creates a random integer which is within 25, like value under 25, and the size of the array needs to be 5. So what happens is it creates 5 elements. So that's how we create an one-dimensional array with completely random values. So in case of 2 dimension, what we need to do is, the only small difference is in the size. We define the size of the array as per the requirement. So here I'm saying that it needs to be 2 dimension, 5 rows and 5 columns. So when I execute this, so what happens is it creates a 2-dimensional array or an matrix with completely random values. All the values will be generated will be an integer, because we are using random int, and the values will be under 250. So it could be any value between 0 and 250. And moving on to the next one. So let's say now we want to create an array with random values, but we want it to follow a specific distribution. So let's say like we want to create an array by making use of these values, but we want to control how these values should be repeated. So what we specify here is we specify next to it the probability. So when we add up all these, the value should add up to 1. And so what happens is in this array, 1 will be repeated for 10% of times, 2 will be repeated for 20% of times, like as per the probability here, and 3 will be like 40% of times, and so on. So when we add all these, the values should sum up to 1, and then the size of the array is like it's one-dimensional with 100 elements. So when I execute this, what happens is it creates an one-dimensional array with all these values, but how often these values are repeated will exactly follow the probability distribution that we have specified here. So whenever you want to create an array with random values, but you want to control how the values should be repeated, then maybe you can make use of the probability and specify how often they should be repeated. And you can see, like as we specified, 3 should repeat like 40% of times. We can see like more number of 3s here. So when you do a count of all these like individual elements, a distinct count of all the elements, then you can exactly find that they will be aligned to the probability that was defined here. So that's about the topic today. So far we have covered about We have covered about how to iterate through the elements of an array by using for loop as well as by using nditer functionality, and how to manipulate an array like from one dimension to multi-dimension, as well as vice versa, and how to make use of transpose, and finally how to create an array with completely random numbers and how to specify its distribution. So the work for the exercise to try at home would be these. Let maybe try to create an array of one dimension array of length 100, and try to print only the even numbers. So maybe you need to use the iteration, and maybe along with iteration you might have to use a few numerical operator or like a few functionalities to ensure that you print only the even numbers and not the odd numbers. And the next exercise is to create an one-dimensional array with random values, convert it into 3 dimensions, and maybe try to do vice versa, and try to implement row axis on an 3-dimensional array, and try to use transpose on 3-dimensional array, and see how they are, like how similar or how different they are, to just better understand all those functionalities. So that's about the topic covered for today. So I have tried to cover like as much as possible, like all the key topics on all these 3 topics here. But it would be advisable for you to spend some time, read through the NumPy documentation, and go through the details about how else these can be implemented, like how best the iteration can be implemented apart from what we have covered today. So it helps you in building a strong foundation. So that's about it for today. I hope you have learned something new. So if you liked if you have learned something new today, please give a thumbs up and subscribe to the channel for regular contents about data science. And I hope you will stick with me in learning data science in this 100 days. Bye for now. See you in the next session. See ya.